So let's go back and let's select that. We're going to select X to be days. We'll hit Tab again, and then we'll, for the Y-axis, select Views for Y. And when we look at this, it doesn't look curvy at all. It looks like a pretty straight line, so we know that we are looking for a straight line or a linear relationship here. So let's go back and let's take a look at a linear relationship with this data. So we know that a linear relationship follows the model y equals mx plus b, where these variables, that m is my slope, it's how fast it's moving, it's like a speed, and b is what we have defined in class, what you guys have picked up on, is the starting point. So which one of these can we figure out first? Well, we can figure out slope by looking at that as delta y over delta x. And so let's look at delta y over delta x, and let's do that with this data. How are we going to find the change in y? Well, if we wanted to find the slope of this line, I've asked you guys to pick 2 points in the past. You could pick any 2 points as long as the line that you make through it, you think, closely models what the points are doing. So a lot of you guys, when we studied this, picked the first and last points. First and last point, it's not always going to be that, but you guys thought that in this case, if I pick the first point and the last point, that the line I draw through them will closely model what's going on here. Some of you guys chose the second point and the first point. Some of you chose the 2 middle points. And they're all pretty close. So we'll just go with the first point. Going from 4 to 87, that is a growth of 83 million. Going from 6 to 90 is a growth of 84 million. So my delta y is 83, or the change in views over the change in days. And let's find out what that is. We could leave it as a fraction. We could also come back over here and say 83 divided by 84 is 0.99. That's pretty close to the number 1, but it is not 1, so we're going to call that 0.99. Okay, so that's my slope. So if I look at this model again for a straight line, then it looks like so far what we've got is y is equal to 0.99x. And if you think about it, the way that we did in class, this kind of makes sense. 0.99 is a speed. This right here is telling you how fast it's moving. Not in miles per hour, but in views per day. And x is how many days pass. So we've got a what's in essence is a speed multiplied by a time, and that is going to give us the y value, which is the number of views. So the speed of views per day times the time, or the days, is going to give us what y is, which is views. And we've talked about that a little bit, that what we have in essence here is this is saying views equal views. We said y is views, and 0.99 times x is just another way to say views. So we'll get rid of a couple of these marks. And at this point, we don't know if we have a starting point we need to put in there to adjust the line, but let's think about it for a second. Where do you think the video started? At day 0, meaning when the video was first published to YouTube. Somebody hit post and it went up and it was posted. How many views do you think it had? Well, it makes sense that it would start at 0 views. So let's go back and let's test 0.99 times 6. Do we get something that's close to 4? In this case, no. So let's look at our graph. What we're going to do is menu, analyze, plot a function, and 0.99 times x Well, it looks like it did a pretty good job. So why is it that this point, the first point, 6 comma 4, when we looked at the math, 0.99 times 6, did not give me the number 4? And it looks like it's just a little bit below the line. And we had talked about this in class that, for example, give me a rule that describes some of these points that fell above the line, like 73, 76, and 27, 30. Can we write a mathematical rule that describes those? And what you guys had showed me in class is that you took y would be greater than 0.99x to show me the points that were like up here above the line. And then what if I wanted to look at some points below the line? Then we'd be looking at y is less than the line, or 0.99x. And so it looks like this equation works. It pretty much goes through the center of my points. I don't need any vertical up or down adjustment. Looks like it hits the points pretty well. And so there's our data analysis of the video Call Me Maybe.